In this series, we'll be talking about the Bayes theory. That is the Bayesian inferential statistics. But first, before we talk about the Bayesian theorem, we'll first define what this theorem is. First, the theorem states that the posterior probability is equal to the probability of the likelihood function, which we'll put as this, multiplied by the prior probability all over the marginal likelihood, which we'll write as this. So this is what the theorem states, where first, the probability of theta given D is the posterior probability of the parameter theta, which is this, given the observed data D. So this is the observed data D. That's for this definition. The second one, which is this, the probability of D given theta is the likelihood function representing the probability of observing the data D given the parameter theta. Also, we have this, the probability of theta. The probability of theta is the prior, we call it prior probability. Call it prior probability distribution of parameter theta. Why this D, the probability of this is the marginal, I'll explain all of this, is the marginal likelihood or evidence representing the probability of observing the data D. So what does this mean from our definition? What does this mean? It means that for we to solve any question on Bayesian statistics or on Bayesian theorem, we'll have to find this, which is the likelihood function of any distribution that is given. We'll also find the prior probability distribution of the parameter in question. Here, the parameter in question is theta. So, and this is the marginal likelihood. So it means that if we have this, like what Bayes said, that if we have this, the probability of theta given d to be equal to the probability of the distribution and the prior probability all over the marginal probability. It means that this, to get this, is just the likelihood function. This becomes the likelihood function of the distribution given. It becomes the likelihood function. While this, how do you get this? This will now become the prior distribution. The prior distribution of the parameter. In this case, we have theta. It will now be the prior distribution of the parameter theta, which will also be given as the distribution that you use in comparing any distribution given for the Bayesian statistics. So once you get the prior distribution, all you need to get the posterior probability is just to multiply the likelihood function of the distribution given and the prior distribution given all over the marginal likelihood. So when you get all of these, you get the posterior probability. So it's quite simple. We should also understand that this marginal likelihood, or the evidence representing the probability of observing the data given, this data will now be over all the possible values of, in this our case is theta. So it will now be observing all the possible values of theta, in this case, that is given. So that is how we can solve for the probability, the posterior probability.